In this session, we are going to study about another native data type in Python, which is tuple. So we have already seen list, and list we have seen that there are operations like append, insert, pop, etc., which are basically altering the list. So when you add an element or when you remove an element, you are actually altering the structure of the list. But tuple is a different kind of structure altogether. In short, a tuple is an immutable list. So, the very clear difference between a list and a tuple is that a tuple is immutable or it cannot be changed once defined. So, if we have defined a tuple, we cannot add an element to it, we cannot remove an element from it, we cannot change any element. Only thing that we can do is access those elements. So then we'll see why tuples are used in some time. But for now, it's very important to grasp that a tuple is defined with the help of a simple braces. As you can see, simple braces are here, and the values are comma separated just like list. But whatever you think, whatever you design, whatever you do, a tuple once defined or created cannot be changed. So this is how a tuple t is defined in our case, and we can access the elements either by their index like t0, t1, t2, or t minus 1, or we can even do the iteration through a for loop, etc. But there are no methods to modify the structure, like there cannot be any method to add, append, delete, or change any element. That's the heart of tuple actually. So what is the need of tuple, or what are tuples good for? So very important to note that execution wise, tuples are faster than lists. So if your program is executing using list some set of values, and your program is executing using tuple of those values, the one which is using tuples will be faster. So if you are very sure that you are going to define a constant set of values, and all you are ever going to do in future is just to iterate through it and never modify it, so tuple is the right structure to be used. Secondly, we should be very cautious and careful that definitely this is a good security point as it becomes the right protected data structure. Nobody can modify the structure. For example, we might want to use a structure to store days in a week, and days in a week is not something which is gonna change. So days are always be going to be like Sunday, Monday, Tuesday till Saturday, or months in a calendar year, etc. There are various such structures which do not ever change. So in such cases, the better idea is use the tuple rather than list to get the performance benefits also. And since tuple is immutable, it's very important to highlight that tuple can be used as a dictionary key. So only fundamental to specify a key in dictionary is that a dictionary key has to be immutable. So you can use a string, you can use an integer, and you can also use a tuple. However, a list cannot be used as a key of a dictionary because list is mutable. You can modify the list. Second use of tuple is that tuples can be used in string formatting, and this I'll try to show in practical session to understand how tuples can be used in string formatting, something similar on the lines of C. And then finally we also know how to convert tuples to a list and list to a tuple. So there are built-in functions for that. The tuple and the list only, their nomenclature is sufficient enough to provide us the clear hint of what function does what, and then we'll see how we can achieve all our objectives. So let's go to the practice session now. let's define a structure with just a open simple bracket and close bracket, and then see the type of it. This is a tuple but has no elements. Now if I define a b, a tuple with, let's say, some integers. So now if I see, there are only two methods available which are doing count, which will give you the count of the element you specified in the tuple, or the index, which will give you the index of a particular element in the tuple. There are no methods available to add, append, delete, remove, or pop, or modify the structure in any way, which confirms our understanding of tuple, that tuples are actually immutable structures, or they are immutable lists. So only thing that we can do is access them or find the index certain element, etc., like b0, b1, b minus 1, etc. We can iterate using a for loop also. All those things are going to work, but we cannot modify them. Now let's try to understand that if given a list, how can you convert it into a tuple, and given a tuple, how can you convert to a list. So b is a tuple, as we just saw. Type of b is tuple. We can use inbuilt function list to convert this to, and our c is, of all these elements 34, 45, 36, 30, 21, it's converted to a list. We can also check the type of c, which is now obvious because of the brackets. This is a list, and if this c is list, we can convert it back to a tuple using inbuilt function which is called tuple only, and now this becomes a tuple. So inbuilt function list is used to convert this tuple to a list, and inbuilt function tuple will convert a list to tuple, and list function will convert a tuple to list. So this is a useful functionality. Also, we had discussed that we'll be understanding how tuples are used for string formatting in a typical C fashion. So there are two ways of printing things. Example, let us say in a string we have two mixed values. One can be an integer, another can be a string. So let's say I store age as an integer, 32, and I store company as a string, Google. So if I want to print a string something like my age is 32 and I work for Google, then a simple print statement could look like, now this is important because I need to typecast it to str, otherwise I'll get the error that you cannot add an integer to a string. So what I can do is, since age is an integer value and I work for, this is by default a string, so this works in a sense. Imagine if we had to actually format the string specifying some 10 or 15 parameters. This would look very odd to every time do typecasting like it and adjust the spaces, etc. So another way in which we could have achieved this is in the style of C, by using the format specifiers. My age is %d. Now I understand this is an integer, and I work for %s, and this is a string, and then use %sign, and then the tuple specify in the order this is required. So with first %d, the value is from age. With this %s, the value has to come from. So in this case, to format strings, we have to use tuples. And this also works similarly. This is another use case of tuple, which is interesting. I would also like to discuss another important use case of tuple. You can define a function, let's say calc, and let's say I have d is equal to x plus y and e is equal to x minus y, and I want to return both these values. Till now what we have seen is we are returning usually the single values, but this time we are returning a tuple of values. So if you want to return multiple values, we can also return them using our tuple, and also we can capture them similarly. So since it's returning two values, we can capture using, let's say, k comma l is equal to calc of 45 comma 32. Now 45 plus 32 is 77. So d is 77, which is returned stored in the first value k. And then 45 minus 32 is 13, which is captured in e and then passed back to l. So in this way, we can actually return multiple values from a function using tuple and capture them back over here.